So now the next instruction in this logical instruction group is CMP. The meaning of this CMP means compare with accumulator. So here the purpose of this instruction is it is going to compare two numbers. So one by default, one number will be the accumulator content and the second number should be specified as an operand by the use of the register or memory. So here whenever these two numbers will be compared, then according to their comparison result, that their carry flag and zero flag will be showing their result over there. So first of all we'll see their opcode here. So their opcode is CMP. Their opcode is CMP and their operand will be 8-bit register or memory. So their size, machine cycle, test states we'll see later. So here we'll see their functionality first. So what it will happen if the accumulator content, for example, if their accumulator content is lesser than the content of register or memory, then what it will happen that if A is lesser than the register or memory, so here this comparison is happening by the use of subtraction. So here whatever is the content of A, from A, that register or memory content will be subtracted, and as per the subtraction result it is going to reflect that over the zero and carry flag. So in this sense what it is saying that if accumulator content is lesser than register or memory, so it is giving that the result will be negative. So due to that reason their carry flag is set here. Carry flag will be set here and the result will be negative, that is non-zero. So here zero flag will be reset here. So zero flag will be reset here. Similarly, if this accumulator content is equal to this register or memory content, then what will happen that this result will be zero. So carry is not required here to perform the subtraction. So due to that reason this carry flag will be here as a 0 itself and the subtraction result will produce entire bits will be 0. So due to that reason their 0 flag will be set here. Now if accumulator content is greater than this register or memory, then by that time to perform this subtraction there is no carry required or borrow required, that result will be positive. So due to that reason this carry flag will be reset, as well as this zero flag will be reset because result is positive here. So what is the major point? That whenever it is performing this subtraction here, so this subtraction is happening with the help of 2's complement subtraction method which is adopted by this 8085. So after performing this subtraction internally by the microprocessor, as per the result it will be showing to this carry flag as well as zero flag, but it is not going to change the content of accumulator or the content of register or memory. So if you see that previously whatever I had explained under the arithmetic instruction, by that time as per the subtraction result that accumulator content was modified, but here we are not performing the subtraction, we are adopting this subtraction method to compare two numbers. So our main purpose is to compare two things here, not to perform the subtraction. Subtraction is the technique which is giving the result here to compare two numbers. So due to that reason, as per the subtraction result, this carry zero flag will show these values over there as per the number taken. So if whatever number it has taken, by testing the content of carry and zero flag, we can say that whether accumulator content is greater or lesser or equal. But by the end of the operation, that accumulator content or register or memory content is not going to be changed anywhere. So what about the other flags? So here in the note we can write down, that sign, parity, auxiliary carry are also modified as per the subtraction result. As per the subtraction result. But 0 and carry flag, 0 and carry flags to reflect the result of the operation, to reflect the result of the operation. So the intention here is, as per the subtraction, sign 0 parity flag also is going to change, but whether A is greater or lesser or equal, that can be identified by testing this carry and 0 flag. So that is the intention here. So now I can give you the more clarity over this by taking one of the example to compare two numbers. So let's say, for example, I am taking here let's say I'm taking here the instruction as CMP B. So here, before going to execution of this instruction, let's assume that the accumulator content is here, this accumulator content is 57H and this B register content is 62H. B register content is 62H. So with the help of this instruction, we have to say whether A is greater or lesser than B. So that how it is doing internally, that things we have to understand here. So this is before, this is the data before execution of this instruction. So how it is going to perform? It is going to perform A minus B. So how to do this? We have to take it here, A plus minus of B. So this can be written A plus 2's complement of B, 2's complement of B is equivalent to minus B. 2's complement of B is equivalent to minus B. So whatever is this B taken as a 62H, whenever we will take their 2's complement, then that will be representing minus 62H, and if that will be added with this 57H, then it is called the subtraction of 57H and 62H. So 62H is going to be subtracted from this 57H by the use of this 2's complement method. So here this A is taken, this content of A, it has 57H, and their binary pattern, it can be written 0101, and for the 7 it will be 0111. Now for this B, whatever is this B value, so this B value it has given as a 62H. So in their binary pattern, this can be written 0110, and for this 2 this can be written 0010. So now if we take it here, 2's complement of B, that is equal to minus 62H. So here if we take the 2's complement of these values here, so this 0 will be as it is, and the first non-zero value is this 1 here. So after first non-zero values, what are the bits we have to alter? 0 will change to 1, 1 will change to 0. So that is giving the direct 2's complement of a given number. So here it will become 1, 0 will change to 1, then this 0 will change to 1, then this 0 will change to 1, then this 1 will change to 0, this 1 will change to 0, this 0 will change to 1. So this, whatever we got this value here, so this value is giving the representation of minus 62H. So that should be added here with this A57H. So here we can write 2's complement of b. So this value it is 1 0 0 1 1 0 0 1. Then this will be 1110. So this value I had copied here. Now we need to add this. So we need to add this, that is called 2's complement subtraction method here. So from the first stage 1 plus 0, it is here 1. From the second stage 1 plus 1, sum will be 0 and carry will be 1. From third stage 1 plus 1 plus 1, sum bit is 1, carry bit is 1. So from the fourth stage 1 0 1, so sum will be 0 and carry will be 1. From the fifth stage 1 1 1, sum will be 1 and carry will be 1. From this sixth stage 1 0 0, so sum will be 1 and carry will be 0. From the seventh stage 1 plus 0, that sum will be 1, carry will be 0. And from the eighth stage, which is called last stage, so this is here 0 1. So this 0 1, 0 plus 1, sum will be 1 and carry is 0 here. Carry is 0 here. So previously whenever I had explained about that 2's complement subtraction method, by that time I had explained that whatever is the carry status as per the 2's complement subtraction method, we need to take their complement as a final result. So here complement carry, as per the procedure we need to complement carry. So here this result will be 1 and then this will be the 8-bit result here. So this will be 4 times 1 0 1 0 1. So as per this result, it is going to reflect over the flags. So here now we will write about the flags. So this is sign flag, 0 flag, auxiliary carry, parity and carry. So if you see that this MSB bit is 1 here, this MSB bit is 1 here. So sign flag will be 1. Result is non-zero. Result is non-zero. So 0 flag will be 0. From the fourth stage, from this stage, that auxiliary carry generated here, which is added at this stage. So auxiliary carry will be 1 here. In this subtraction result, if you will see that the number of ones are 6, which is called even. So this parity bit will perform as a even parity. So this bit will be 1 here, and as a carry, this is the status of this carry bit here as per the result. So this carry flag will be 1 here. So this is the impact it is coming over the flags after execution of this instruction. But basically this 0 flag and carry flag is showing the comparison result. So here I hope you understand this procedure, whatever I had tried to explain you here. So why this sign bit is 1 here? If you'll see that this A is 57H. This A is 57H. In terms of decimal, it will be 87. And B is here 62H. So in terms of decimal, it will be 98. If you do their subtraction, then it is coming here as a minus 11 under the base 10. So here if you see that this this content of A is lesser than this content of B. So that is the reason here their carry flag is set. If you see that their carry flag is set, because this is the procedure here for this 2's complement, and this result is non-zero negative value. So that is the reason this 0 flag is reset here. So whether A is greater, lesser or equal, that can be find out by testing the result of this 0 flag and carry flag, and rest of the flag is changing as per this subtraction result. But this subtraction result is not going to be stored into the accumulator after finishing the execution of this. So if you will check it here that after execution of this instruction, the data of accumulator and the data of B register will be same as like before execution of this instruction, whatever we had assumed in this case. So in this case, whatever we had taken this data here, so the data whatever in this example we had taken, so that accumulator content, it will be same as like 57H, and this B register content will be same as like 62H after execution of this instruction. So this subtraction is happening internally to modify or to reflect over the flags, but it is not going, this subtraction result is not going to reflect to the user, to the programmer. It is happening internally by the processor to change this flag as a carry flag and zero flag to reflect the result. So I hope you understand the operation of this CMP instruction. Now we'll talk about their size, machine cycle and T state. So if you'll see that, for example, if I had taken that instruction as a CMPB, it means in this instruction that it is purely English alphabet. So their size will be only 1 byte. And what is the operation? That as an operation, it is taking only opcode from the memory. So that operation is called as a opcode fetch machine cycle. So that is required only one machine cycle, because rest all the parts, flag register is inside the processor, accumulator is inside the processor, B register is also inside the processor. So it requires what the operation has to perform, that opcode only it requires from the memory. Rest of all the resources are available inside the processor itself. So due to that reason, it is required only one machine cycle, and that machine cycle is called by default as a opcode fetch. So here this T state for this opcode fetch is required here as a 4T state. Now if I am writing here as instruction CMPB, CMPM, so here what it is going to perform, it is going to perform that accumulator content is going to be compared with the content of memory location whose address is holded by HL register pair. So let's say if this HL register pair content is 2050H before execution of this instruction, so at this memory location, what is the content? That content will be compared with this accumulator content with the similar mechanism, and as per the result, as per the subtraction result, it is going to reflect over the flags or modify that rest of the flags. So here also that carry flag and zero flag will be used to reflect the result, and rest of the flags will be modified as per the subtraction result. So here also that mechanism functionality of the operation will be same, only there will be changes with this machine cycle. So here as per the size, with respect to size, in this instruction also this consists of only English alphabet, so their size will be 1 byte only. Their size will be 1 byte only to store their opcode. But here as like how to access this memory, how many times we are accessing. So by default, first time it is opcode fetch to get their opcode. Then while decoding and execution of their opcode, that microprocessor is knowing that the second operand which is going to be compared with the accumulator content is not inside the processor, it is outside of the processor, which is inside in the memory, and whose address is holded by this HL pair. So HL pair will use as a memory pointer, and from that location the data will come to the processor, that will be copying into the processor, and accordingly it is going to compare their results, and then as per the result this is going to be reflect over the flags also. So here to complete execution of this instruction, by default first of all it is required opcode fetch, and second machine cycle to read their second operand, it is called memory read operation. So rest of all the parts it is happening inside, rest of all the resources and this operation is happening inside the processor itself. So outside of the processor it is going to access the memory chip two times. One is for the opcode fetch and another one is for the memory read. So their machine cycle will be 2 here, and as we know that as a t state for the opcode fetch operation by default it is 4 t state, and for the memory read it is 3 t state. So here 4 plus 3 total number of t states required for the execution of this instruction is 7 t states. So I hope you understand this instruction with much of clarity, how their carry flag and zero flag is used to reflect the result, and how it is going to change or modify the rest of the flags. Apart from that, the major key point here is it is not going to alter the content of accumulator, it is not going to alter the content of register or memory location content. It is just using that resources or using that data to perform the subtraction internally by the processor, and as per the subtraction result it is going the reflection over the flags, but it is not going to store this subtraction result. So this is the key point of this instruction. You must have to keep it in mind for the further use of this instruction as per the requirement. So I hope you understand this with much of clarity. Thank you.